In today's video, we'll be looking at some geriatric care and aligned health math past paper questions. If you are new to this channel, please hit that subscribe button and that notification bell to be notified whenever we post new videos. Alright, so let's get right into it. So here we have Dr. Manning gives Nurse Scott instructions to administer 50 milliliters of blood to 3 patients in the ratio 2 to 3 to 5. Calculate the amount of blood each patient should get. Alright, so we want to know the amount of blood that each patient will receive. Alright, so let's assume that patient 1 would receive this share right here, patient 2 would receive this share right here, and patient 3 would receive the 5 right here, which represents a half. Alright, now the first thing that we want to know is the total ratio. Alright, and how do we obtain the total ratio? Alright, all we are simply required to do is to add these ratios that we got. Alright, so we'll add 2 plus 3 plus 5. Alright, so this will give us 10. So 2 plus 3, that's 5, plus 5, that's 10. Alright, so the total ratio would have been 10. Now, if we want to find out the share that the first patient, alright, so the first patient would have obtained, so let's call that one the first patient. We can simply do what? Put that patient share, which would have been 2, that's the first share here, 2 over the total ratio, which is 10. And then we'll multiply that by the total amount of blood, which is 50 milliliters, all right? And we don't have to put the unit in this thing as yet. All right, and we could approach this in many different ways. We could have simplified from here, but I'm going to, of course, you can do that. You can simplify here. So 10 going to itself 1, 10 into 50 goes 5 times, 2 times 5, that would give it a 10. All right, but just in case, I guess this would have been the simpler way out. So you put the 50 over 1, then you multiply across. All right. So numerator times numerator, 2 times 50, that's 100. 10 times 1, that's 10. And now 10 goes into 100 10 times, all right? Which means the first patient would receive 10 milliliters out of the 50 milliliters of blood, all right? And we'll repeat this thing until we complete the question. So let's look at the amount of blood that patient 2 would receive, all right? So patient 2 would receive, and we have the same approach. So we'll look again at the share that the patient 2 would have got, which is 3, out of the total ratio. So we'll have 3 over 10 times the amount of blood that we're dealing with. And again, we can put this over 1 and multiply across. So 3 times 50, that's 150. 10 times 1, that's 10. All right. And 10 goes into 150 15 times. All right. And you can always use a calculator to obtain those results. Now, let's look at the final one, which is quite easy rather, because patient 3 must obtain what's left. All right. Of course, we could put the 5 over 10 times 50 just the same. You can do it like that. Or we can say the third patient, all right, we can say the third patient will obtain what's left, all right? So after we add what patient 1 and patient 2 would have obtained out of the 50, we can subtract that from the 50 milliliters, all right? So we can say what? 50 milliliters minus what? Patient 1 would have obtained 10 milliliters of the blood, and patient 2 would have obtained 15. So what we're going to do is to add both of these share and then minus that from the amount of blood, and that will give us the amount of blood that will remain. all right? And again, this is just one way how you can do it. You can continue just like the others and use 5 over 10 times 50 over 1 and continue the steps just like we did the previous two, all right? So this is 50 minus 10 plus 15, that's 25. 50 minus 25, that's 25 milliliters, all right? And that is pretty much how we would obtain the solutions for question 1. Now let's look at question 2. All right, so let's look at question 2. So the charge nurse has instructed the male orderly to use a solution of 10 milliliters of bleach to 100 milliliters of water to clean a spill in the male surgical lab. What is the ratio of bleach to water? All right. What we want to do now is to actually find what? The ratio of bleach to water. All right. So we know that we're supposed to use what? 10 milliliters of bleach, 2, and we use a colon to represent the 2 as it regards to ratio to 100 milliliters of water. All right. And we can always reduce this thing. So what we're going to do is to divide both these numbers by the highest common factor for both numbers. All right. So what that simply means, we're going to divide both the 10 and the 100 by the highest number that can go into both these numbers without leaving a remainder, right? And of course, that would be 10. 10 can go into itself without leaving a remainder, and 10 can go into 100 without leaving a remainder. We call that the highest common factor, right? So 10 go into itself 1 time, 10 go into 100 10 times, all right? And we can put that in bracket and add the unit out here, which is milliliters. So 1 to 10 milliliters, all right? And this is pretty much how we treat with question 2. All right, so here we have question 3. Mr. Crosby's baseline weight measurement was 170 pounds when he was admitted to the hospital. After surgery, his weight was 110 pounds. How much weight did Mr. Crosby lose? Give your answer in pounds and kilograms, given that 1 kilogram is equal to 2.2 pounds, all right? So they gave us some information there as it relates to the conversion of kilograms to pounds, all right? So what we want to find is Mr. Crosby's weight loss, all right? Because it asks us how much weight did Mr. Crosby lose, all right? So how do we obtain his weight loss? How do we go about this? Now what we're going to do is to subtract his weight after surgery from his original weight before surgery, all right? So to obtain his weight loss, we are going to have what? 170 pounds minus 110 pounds, all right? And this will give us what? 170 minus 110, that's 60 pounds, all right? So this would have been the amount of weight that he would have lost. Now what we want to do now is to convert this 60 pounds to kilograms, all right? Because it asks us to give your answer in pounds and kilograms. So we already obtained our answers in pound. What we want to do now is to convert this 60 pounds to kilogram. And we can use proportion to do this quite easily, all right? So what we're going to do is to compare pounds with kilograms. All right, and remember this key information here. We know that what? 1 kilogram is equal to 2.2 pounds. All right. Now what we want to know now, what is the equivalent of 60 pounds in kilograms? All right, so we don't know what 60 pounds is in kilogram as yet, so we use an X to represent that. And now we can cross multiply. All right, so this will give me what? 2.2 times x, that's 2.2x. Ensure that's on screen. Is equal to 1 times 60. That's 60. And now we can divide both sides by 2.2. All right. So 2.2 cancel 2.2 there. I'm left with x is equal to 27.3 kilograms. All right. And you might obtain 27.2727, but you can round it off to one decimal place and you'll obtain 27.3 kilograms. All right. So this is pretty much how we treat with question 3. All right. So here we have question 4. So Mr. Clark is to receive 2 teaspoons of penicillin suspension every 8 hours. All right. How many milliliters of penicillin suspension would he receive over a 24-hour period? All right. So we want to know how many milliliters of penicillin suspension he would receive over the 24-hour period. So what we want to do now is to first compare teaspoons and hours. All right. And we can use proportion to do this quite nicely. All right. So we know that what? Mr. Clark is to receive 2 teaspoons of penicillin suspension every 8 hours. All right, and we can represent that like that. All right, now we want to know what? How many teaspoons, which means we don't know the amount of teaspoon as yet, of penicillin suspension he should receive in the 24-hour period. And a key thing to note, they ask us how many milliliters of penicillin suspension. They are not asking us to give our answers in teaspoon. All right. They want the answer in milliliters. So what we're going to do first is to find out what? How many teaspoons of penicillin would he receive over a 24-hour period? Then we'll convert that amount of teaspoon to milliliters. All right. So that is how we'll approach this particular question. So what we can do now is to cross multiply. So 8 times x, that's 8x. 2 times 24, that's 48. And we can now divide both sides by 8. So 8 cancel 8, and x is equal to 8 into 48 goes what? 6 times. So this is 6 teaspoons. So he will actually receive 6 teaspoons of penicillin suspension over the 24-hour period. Now what we want to know is the equivalent of these 6 teaspoons in what? Milliliters. So we need to compare what? Teaspoon with milliliters. All right. So in order to solve the question, we need to know the conversion. All right. Now the conversion of teaspoon to milliliters is a key thing that we have to know. 1 teaspoon is equal to what? 5 milliliters. All right. So that's very important. So you probably want to make a note of that. So 1 teaspoon, let me put that over here. 1 teaspoon is equal to 5 milliliters. All right. That's a very key thing to know. All right. Because it wasn't given in the question. So you have to know that yourself. All right. So what we want to do now is to convert this 6 teaspoon into milliliters. So we don't know the equivalent in milliliters for this 6 teaspoon here. All right. So what we can do now is to cross multiply. So x times 1, that's x. 6 times 5, that's 30 milliliters. All right. And that's pretty much our answer. So we can, even if you so choose, you can write a statement. All right. Just to give clarity to what you would have done here. So you can probably write, therefore, Mr. Clark would receive 30 milliliters of penicillin suspension in the 24-hour period, all right? If you so choose, all right? Just to give clarity to what you would have done. Now let's look at question 5. All right, so let's look at number 5. And here we have part A and part B. So let's look at part A first. Mrs. Martin's doctor has ordered ½ ounce of medicine at 8 a.m. and 3/4 ounce, which is 3/4 ounce of medicine at 2 p.m. How much medicine will she receive? All right. So I want to know how much medicine would she receive. Now, all that simply requires us to do is to add the amount of medicine that she would have obtained at 8 a.m. to the amount of medicine that she would have obtained at 2 p.m. All right. So she received ½ ounce of medicine at 8 a.m. and 3/4 ounce, which is 3/4 ounce of medicine at 2 p.m. So to actually obtain the amount of medicine that she would receive, we'll need to add both of this thing, all right? So we can say amount of medicine received would be equal to, and we'll add the fractions, all right? So we'll add 1 over 2 plus 3 over 4, all right? And if you're not comfortable with fractions, I'll have a video on fraction. That is a very detailed video on how to manipulate fractions in the description section below, all right? Titled Easiest Way to Learn Fractions. So you want to check that out if you're not comfortable with fractions, all right? So we're going to add 1 over 2 plus 3 over 4, all right? And we're going to take the LCM method. Of course, there are other ways how we could do this, but let's look at the LCM method. Now, we want to find the lowest common multiple, all right? Any multiple actually works, but let's find the lowest common multiple. So what's the lowest common multiple for 2 and 4? That's the lowest number that both 2 and 4 can go into without leaving a remainder. All right, that number would be 4. So 2 can go into 4 and 4 can go into 4 without leaving a remainder. So 2 go into 4 2 times. We'll use that 2 to multiply the corresponding numerator right here. So 2 times 1, that's 2, plus 4 into 4 goes 1 times 3, that's 3, all right? And this will give us a 5 over 4, all right? Which is the same thing as, let me see, as 5 over 4 ounce, all right? Or we could write this in mixed fraction, which is 1 and 1 over 4 ounce, all right? Now let's look at this part now. Give your answer in centimeter cube. So I want to give our answer in centimeter cube, but before we can do so, we want to know the conversion, all right, from centimeter cube to ounce, or from ounce to centimeter cube, all right? Now, what we want to do is to convert this 5 over 4 ounce, which is the same thing as 1 and 1 over 4 ounce, to centimeter cube, all right? So let's see how we do that now, all right? So remember what we are dealing with. We want to convert the 5 over 4 ounce to centimeter cube, all right? Now, the conversion from ounce, so 1 ounce to centimeter cube is 1 ounce is equal to approximately 30 centimeter cube, all right? Now, what we can do now to convert this thing is to set up a proportion with ounce and centimeter cube, or cubic centimeter. So 1 ounce is equal to 30 centimeter cube. And what we can do now, we want to know what 5 over 4 ounce, what's the equivalent of 5 over 4 ounce in centimeter cube. So this we don't know as yet. So this is what we'll have. We'll cross multiply. And don't let this fraction aspect of the question intimidate you. The same principle applies, all right? So x times 1, that's x, is equal to 5 over 4 times 30, all right? And again, we can simply put this 30 over 1 and then multiply across, all right? So we can say what? 5 times 30, that's 150 over 4 times 1, which is 4, all right? So 150 divided by 4 will give us 37.5 centimeter cube, all right? So if we convert the 5 over 4 ounce to centimeter cube, or cubic centimeter, we'll obtain 37.5 centimeter cube, all right? Calculate the flow rate for an IV of 1000 milliliters of normal saline to be infused in 6 hours, all right? The drop factor of the infusion set is 20 drops per milliliters, all right? So first thing first, what we want to do is to convert this one. We want to know how many drops we can obtain from this 1000 milliliters, all right, of normal saline. Now what we want to do now is to use proportion to obtain that. So we're going to come to a proportion with drops and milliliters. All right, so we know that we can get 20 drops per milliliters, which is the same thing as 20 drops is equal. We can get 20 drops from 1 milliliters, all right, of normal saline. Now, what we want to do now is to obtain how many drops, which we don't know as yet, so use X to represent that, we can obtain from 1000 milliliters of normal saline, all right? And now we can cross multiply. So what we'll get here is X times 1, that's X, is equal to 20 times 1000, that's 20,000, all right? So we can get 20,000 drops from this 1000 milliliters of normal saline, all right? Now what we're going to do now is to calculate the flow rate, all right? So the flow rate will be equal to, we're going to have the total drops, which is the 20,000 drops that we'll get from the 1000 milliliters of normal saline over the time, all right? So that's the flow rate. So the flow rate is the drops per time, all right? Once you hear the term rate, you know that you're comparing something to time, all right? So what we want to do now is to have this 20,000 drops. So we want to pretty much calculate the drops per hours, all right? So that's what we want to do when they ask us to calculate the flow rate. We want to know the drops per hour, all right? So we'll have this 20,000 drops because this is the equivalent for 1000 milliliters, 20,000 drops. We can get 20,000 drops from this 1000 milliliter right here. And we want the time that we're dealing with is the 6 hours right here, right? Because we want to know pretty much the flow rate for an IV of, and remember, we converted this 1000 milliliter to 20,000 drops, all right? So the flow rate for an IV of 20,000 drops of normal saline to be infused in 6 hours, all right? So once we calculate this thing, we would have obtained our answers, all right? So what is 20,000 divided by 6? That's 3,333.33, all right? But I'm going to stop at 1 decimal place. And what I obtained here is the flow rate, all right? Which is drops per hour, all right? So this would have been my unit for this particular example, all right? So 3,333.3 drops per hour, all right? So that's pretty much how we treat with this particular question. All right, so let's look at question 7, all right? So Jacqueline received 3 teaspoons of penicillin suspension every 6 hours, all right? How many milliliters of suspension would she receive in a 24-hour period, all right? So I want to know how many penicillin suspension she will receive in the 24-hour period. Now, notice that they ask us to give our answer in milliliter, all right? So they say how many milliliters of suspension would she receive in a 24-hour period. So what we want to do first is to find out how many teaspoons of penicillin suspension she'll receive in the 24-hour period and then convert that amount to milliliters, all right? So we can set this thing up using proportion as usual. So let's first find out, all right, how many teaspoons she'll receive in the 24-hour period, all right? So we know first that she received 3 teaspoons of penicillin suspension every 6 hours, all right? So she received 3 teaspoons in 6 hours. What we want to find out now is how much teaspoon that we don't know as yet. So I use an X to represent that. She'll receive in the 24-hour period, all right? Now what we can cross multiply. So 6 times x, that's 6x is equal to 3 times 24, and that's 72. Alright? Now what we're going to do now is to divide both sides by 6. So 6 cancels 6, and x is equal to 12 teaspoons. Alright? Now what we want to do now is to convert this 12 teaspoon to milliliters. Alright? So how do we do that? Again, we can set up a proportion now with teaspoon and milliliters. So what do we know? We know that 1 teaspoon is equal to 5 milliliters, all right? However, this information wasn't given in this question, so this is something that you'll want to know, all right? So 1 teaspoon is equal to 5 milliliters. So that's something that you have to know personally, all right? So 1 teaspoon is equal to 5 milliliters. We want to know what's the equivalent of 12 teaspoons in milliliters, which we don't know as yet. So I use an x to represent that. Again, we cross multiply. X times 1, that's x. 5 times 12, that's 60. So this is our answer, 60 milliliters. All right. So she'll receive 60 milliliters of penicillin suspension in the 24-hour period. All right. So, and again, if you want to write a statement about this thing, you can always do that to give clarity to what you would have done. All right. So this is pretty much how we treat with question 7. All right. Now let's look at question 8. So Nurse Gail give 5 patients Panadol liquid during the course of the day. All right. The dosage were 5 milliliters, 10 milliliters, 25 milliliters, and 18 milliliters. All right. What is the total dosage for those patients? So once it's to ask us what is the total, then that simply means we're required to add all of these dosage. All right. So we have 4 numbers. All right. And I'm going to write them from largest to smallest coming down. So start with the largest one, which is 25 milliliters. Then we have 18 milliliters. Then we would have the 10 milliliters, then the 5, all right? And of course, it could have used a calculator to do this quite easily, all right? So 5 plus 8, that's 13. 13 plus 5, that's 18, all right? So bring the 8, carry the 1 there. 1 plus 2, that's 3, plus 1, that's 4, plus 1 again, that's 5, all right? So this is 58 milliliters. All right. And again, if you want to write a statement to give clarity to what you would have done right here, you can say, therefore, the total dosage for those patients would have been 58 milliliters. All right. And of course, that's optional to you if you want to give clarity to what you would have done. All right. So this is pretty much how you treat with question 8. All right, let's look at question 9. All right, so Mark Land's body has been elevated at an angle of 65 degrees. If his body forms a complementary angle, what is the size of the other angle? All right, so complementary angle, if we have 2 angles and those angles adds up to give us 90 degrees, we refer to that as complementary angle. All right, so this pretty much means that both these angles that we're dealing with in this particular question would have been equal to 90 degrees, all right? So if one of the angles is 65 and I want to obtain the size of the other angle, then I pretty much need to minus the 65 from 90, all right? And that will give me the size of the other angle. So we can say that the other angle would be equal to 90 degrees minus 65 degrees, all right? And if we minus 65 from 90 degrees, we'll end up with 25 degrees, all right? So therefore, the size of the other angle would have been 25 degrees, all right? And this is pretty much how you treat with question 9. All right, let's look at question 10. 6 patients at the Newport Nursing Home consume 6 ounces of water 3 times per day with their medication. Alright? How much water do they consume per day? Give your answer in ounces. Alright? So a key thing to note is the amount of times that they actually consume the 6 ounces of water. Alright? So they consume 6 ounces of water 3 times per day. Alright? So if we want to know, and another thing to look at is that they ask us what? How much water do they consume per day? And they want us to give our answer in ounces, which is the unit that we would have been looking at here already. Alright, so how do we go about finding this? We know that they receive 6 ounces of water 3 times per day. So if we want to know the total ounces of water, so total amount of water, would be equal to what? Being that they receive the 6 ounces 3 times per day, I can obtain the total amount of water that they'll receive by simply multiplying 3 times the 6, alright? And this will give me 18 ounces. Alright, so that would have been 18 ounces. So the total amount of water that they'll receive per day would have been 18 ounces. So that's pretty much how you treat with question 10. Alright, so let's look at question 11. Alright, so Mr. Smith medication bill for 6 months at the nursing home is $250,000. Management has decided to give him a 25% discount. What amount will Mr. Smith be required to pay? Alright, so first thing first, we want to know the equivalent in dollars for the 25% discount. Alright, so how do we go about finding this? Alright, so the discount will simply be equal to, we can represent 25% as 25 over 100, alright, times the amount of money that we're dealing with. So we want to find 25% of $250,000. So this is how we set that up, alright. Now we can put this thing over 1 and multiply across, alright. So what is 25 times 250,000? That will give me 6,250,000, alright, over 100 times 1, that's 100, alright. Now if I divide 6,250,000 by 100, you can look at this from the perspective that the zeros cancel each other out. Alright, or you could have used your calculator to do this part of it. Alright, either way, we'll be left with $62,500. Alright, as you can see there. So the discount would have been $62,500. So after he would have been given the discount, the 25% discount simply means he would get $62,500 off the original cost, alright? Which means if we want to get the amount that he will be required to pay, so the amount that he'll be required to pay would be equal to, we'll have to do what? Take the discount from the original cost, alright? So that's 250,000 minus the discount, which is what? $62,500, alright? And if we subtract this thing, and again, you can use the calculator to do this part of it. So if you do that, you will obtain $187,500 as your answer, alright? So after Mr. Smith would have been given the discount, he will be required to pay $187,500, alright? And this is pretty much how you treat with question 11, alright? Now let's look at question 12. Alright, so here we have question 12, alright? So John receives this series of medication. 1.15 milliliters, 0.5 milliliters, 3.2 milliliters, and 1 milliliters on Tuesday. What is the total dosage he received for the day? Alright? And again, once I ask us what is the total, that simply means we're required to add all these things. Alright? So to obtain the total, we're required to add all these milliliters of medication. Now, how do we go about doing this? So let's start from here. So we have 1.15. We have 0.5. So 0.5. Then we have 3.2. Right, and here we have 1. Now we can put a point here and fill in. We can fill in the extra spaces. Use 0 for the placeholders. Alright. And now we can add all these numbers. Now 5 plus 0 plus 0 plus 0, that's 5. 1 plus 5, that's 6. Plus 2, that's 8. Plus 0, that's still 8. 0.1 plus 3, that's 4. Plus 1, that's 5. Alright. So our answer would have been, so the total dosage he received for the day would have been what? 5.85 milliliters of medication. Alright. So this is pretty much how we treat with question 12. Now let's look at question 13. Alright. So the area of a square tabletop is 144 meters squared. What is the perimeter of the tabletop? Alright. So we know that in order to find the perimeter of a square, we are required to add. Alright, let's look at question 13. Alright. So the area of a square tabletop is 144 meters squared, or squared meters. What is the perimeter of the tabletop? Alright. So I want to know the perimeter of the tabletop. Now what do we know about squares? All the sides must be equal. Alright. And to obtain the perimeter of a shape, we want to know the length of the outline. Alright. And being that a square has 4 sides, then we are required to add the length of all the sides. Alright. So first thing first, we know that we need to find the length of each side. But here they gave us the area of the square tabletop. Alright. So we know that the area of the square tabletop is 144 meters squared. Alright. Now, what else do we know about the area of a square? The formula for the area of a square is that what? The area is equal to the length squared. Alright? So being that they have given us the area, we know what A represents. A is the same thing as 144. So I can replace the A with 144. And that is equal to the length squared. Now, we are required to transpose this thing now, alright? And the key thing about transposition, once you want to get rid of something, you are required to do the opposite of that thing, alright? So here we have a square right here. So to get rid of the square, we have to do the opposite, which is the square root. And another thing about transposition, whatever you do on one side, you are required to do the same thing on the other side to keep the equation balanced. So we have to square root this side as well, alright? So the square root sign will cancel the square sign right here. So L is equal to the square root of 144. And if you put that in your calculator, you will get 12 meters, alright? So notice the length is in meters and not meters squared, alright? So the unit for length would have been meters, alright? So we can now find the perimeter. So the perimeter would have been equal to what? Adding the length 4 times. So 12 plus 12 plus 12 plus 12. Alright? So what is 12 plus 12? That's 24. Alright? So that's 24. Then we have another 12. That's also 24. What's 24 plus 24? That's 48. Alright? Meters. So therefore the perimeter would have been 48 meters. Another way how you can find the perimeter, the formula for the perimeter of a square is 4L. Alright? So adding 12 4 times is the same thing as multiplying 12 by 4, alright? So if we want to obtain the perimeter, we could have also used. So this is an alternative method to find the perimeter, alright? So we could have simply multiplied 4 times the length, which is 12. 4 times 12, that's 48, alright? Meters. So you choose, alright? So you could have done this part either way, alright? You can do it like that, or you can do it like this down here, alright? You choose. So this is pretty much how we treat with question 13. Now let's look at question 14. Alright, so let's look at question 14. So the perimeter of a rectangular garden is 16 feet. What is the width of the garden if the perimeter is 5 feet? Alright, so what I'm going to do is to highlight first the perimeter. So let's look at what we have. We know that the perimeter is 16 feet. Alright, and we know the length. They give us the length, which is 5 feet. Alright, now what we could do is to actually draw the rectangular garden. Alright, I do a rough sketch of it. So this thing is not drawn to scale. So let's see what we can do now. So the length of this thing, so the length is equal to 5 feet. So down here would also be equal to 5 feet. And the width, now they ask us to find the width. So what is the width of the garden? So we know that this would be the width. And here will also be one of the width as well. Alright. So we know that the formula to find the perimeter. So the formula to find the perimeter of a rectangle is what? 2L plus 2W. Alright. Or you could just say add all the sides. Alright. So W plus L plus W plus L. You realize that you'll be adding 2W and 2L. Alright. So that's the same thing as 2L plus 2W. So what we can do now is to find the value of W, which will give us the width. Alright, so remember the perimeter is 16 and we have 2 times the length, which is 5. Alright, plus 2W. Alright, so here we'll have now 16 is equal to 2 times 2 with the 5 in bracket is the same thing as saying 2 times 5. 2 times 5 is 10 plus 2W. Alright. Now what we want to do now is to transpose this thing. Alright. And I'm going to explain what transposition is all about. Now what we want to do is to make W the subject of the equation. What that simply means, we want W on one side of the equal sign by itself. That simply means we need to get rid of the 10 and the 2 from over this side. Alright. Now how do we go about doing that? Now what we are required to do, to remove something, we need to do the opposite of that thing. And whatever we do to one side, we are required to do the same thing on the other side to keep the equation balanced. Alright? Now, to get rid of this 10, we are going to get rid of the 10 first. So we are going to get rid of the things that are furthest away from the W first. Alright? So we want to get rid of the 10 first. So here we have the 16 on that side, we have 10 over here. To get rid of 10, we can simply do the opposite, which is the minus 10. Alright? And we still have the plus 2W over here. Now we minus 10 on that side. Alright? That wasn't always in the equation. That means we're required to minus 10 on this side also. 10 minus 10, that's 0. Those things cancel. 16 minus 10, that's 6, is equal to 2W. Alright? Now what we're required to do now, again, we are to remove this 2, we have to do the opposite of the operation that is taking place. So 2W is the same thing as 2 times W, which is multiplication. So to get rid of the 2, we have to do the opposite, which is to divide by 2. Alright? And if I divide this side by 2, I have to do the same thing on this side also. Alright? So 2 cancel 2, and I'm left with W is equal to 2 into 6 goes 3 times. So in other words, the width is 3 feet. Alright? And you can always test this out. So if the width is 3 feet, alright, so this would also be 3 feet. you can check it out, alright? So when you add up all the sides, you should obtain the perimeter to be 16. So 5 plus 3, that's 8, plus 5, that's 13, plus 3, 16, alright? So that proves that our answer was correct, alright? So this is pretty much how you treat with question 14, alright? Alright, so let's look at question 15, alright? So what is the area of the triangle below, alright? So here we have the perpendicular height and we have the base, alright? So what is the area of a triangle? Remember this formula? The area of a triangle is equal to what? Half base times height, alright? And another way how we could write this formula is what? The area of a triangle is equal to the base times the height over 2. Same thing as half base times height, alright? So we use this one. So here we have the base, which is this line down here, is 11 centimeters times the height, which is what? 6 over 2, alright? So how do we treat with this thing? So 11 times 6, that's 66 over 2, alright? So what is 66 divided by 2? That's 33 centimeters squared, alright? So because we're finding area, measure area in squared units, so our result, the unit for our result would have been centimeter squared. If these units were in meters, then our result would have been meters squared, alright? So once you're treating with area, your unit will be in squared units, alright? So that's pretty much how we treat with this question, alright? And we could look at what will happen if we use the same formula over here. So you choose which way you want to do it. So we could have half times the base, which is 11, times the height, which is 6, alright? And we can say what? 2 into itself goes 1, 2 into 6 goes 3. 3 times 11, that's 33, times 1, 1 times 33, same 33, alright? Centimeters squared, alright? So don't forget the unit. Must be in squared units, alright? Once you're dealing with area. So that's pretty much how we treat with question 15. Let's look at question 16. So given a cylinder with the radius 5 centimeter and height 8 centimeter, find the volume of this cylinder. Take pi as 3.14 using the formula. So this is the formula for the volume of a cylinder, pi r squared h, alright? So that's the formula for the volume of a cylinder. So in other words, we know that the volume of the cylinder is equal to pi r squared h. Now what do we know now? We know that they told us to take pi as what? 3.14 times r, what's the radius? The radius is 5, and they want us to square whatever the radius is, times h, which is the height. The height is what? 8 centimeters. Alright. Now what we're required to do now, we can expand this thing some more. So 3.14 times 5 squared is the same thing as 5 times 5 times 8, alright? And you can just simply plug in these things in your calculator, alright? And if we do that, what would we get? We'll obtain 628 centimeter cube, alright? So just like how we look at the previous question when we were dealing with area, our unit was in squared units. When we're treating with volume, our unit will always be in cubic units, alright? So this is the same thing as cubic centimeter or centimeter cube, alright? So this is how we treat with question 16, alright? Alright, let's look at question 17. So Mrs. James is a new patient who you have been asked to admit to the facility, alright? She weighs 130 pounds. Convert her weight to kilogram, alright? Now remember, a key thing to know, it wasn't given in this question. So we want to know that what? 1 kg is equal to 2.2 pounds. Very important thing to know, alright? So they want us to convert this 130 pounds into kilograms. So we can do that in proportion, alright? So we'll compare kilograms with pounds. We know that 1 kilogram is equal to 2.2 pounds. And we want to know what is the equivalent in kilogram for 130 pounds. And now we can cross multiply. So we'll have 2.2 times x is equal to 1 times 130. And then we can divide both sides by 2.2. Alright, and see what we'll get. So x will be equal to 59.1 kilograms. Alright, if we choose to round this thing down to 1 decimal place. Alright, so when you put this thing in your calculator, 130 divided by 2.2, you'll obtain 59.0909, and it will continue like that. But we can always convert this thing to 1 decimal place. Alright, and that will give us 59.1 kilogram. Alright, so that is how we treat with question 17. Now let's look at the final question, alright? And that's question 18 for this particular video, alright? So what we want to do is to identify the angles below, alright? So we want to know if these angles are acute, obtuse, right angle, or straight line angle, or a reflex angle, alright? Now looking at this thing, you can conclude that this is an obtuse angle. Now, why obtuse? Now, obtuse angles are angles that are greater than 90 degrees but less than 180 degrees, alright? So these are angles that are greater than a right angle but less than a straight line angle, alright? Now, let's look at part 2 of question 18. Of course, this is an acute angle. Now, what are acute angles? Now, acute angles are angles that are greater than 0 but less than 90 degrees, alright? Alright, so that's pretty much what an acute angle is. Now, let's look at part 3, alright? So, of course, this is an reflex angle. Alright, and reflex angles are angles that are greater than a straight line angle but less than 360 degrees, alright? So that's pretty much what a reflex angle is, alright? And this one is quite easy, alright? So this is a straight line angle. So this is a straight line angle. Alright? So a straight line angle is pretty much a 180, is exactly 180 degrees, alright? So this is a straight line angle. So let's look at the final part of question 18, and here we have a right angle, alright? So this is a right angle. And a right angle measures exactly 90 degrees, alright? This is where we'll end today's video. Please like the video, and if you haven't yet done it, please subscribe to the channel. Until next time, thanks for watching.